because when there is a raid at some petrol pump, it need to be confidential, and the where they are sending a sample, who is going to analyze for them, that should not be disclosed or known to anyone else. But what they did, somehow they have managed, and they have known that whatever sample is collected, that is sent to this specific college, and they are going to do the analysis. So immediately everything was so. Somehow these things, malpractices will also happen in these areas, and there is lot of chance of, because many industries, what they do, they will be buying heavier fractions, because there are in and around them, there are many units which are producing a much heavier fractions, and which they are using in their boiler feed. So they, instead of going for a specifically combustion which is carried out with the help of uh, heavy oils, they will be mixing that with any other ingredients as well, and due to which there is an exhaust which will be actually the emission which are coming out from exhaust will change drastically. So that may create an impact. So that there are a number of aspects to it. So like that, just an incident what I thought of sharing with you. So taking it forward, when I'm talking about ASTM distillation, it is typically done for a product sample and to decide its boiling range. So what it is done in this particular case, they have given, again I will repeat what I have highlighted. ASTM distillation does not have a sharp separation. And why? Because there is no reflux which is available, and there is no pack columns. So whatever is vaporized, that will be condensed and separated out as a distillate. That is what is a basic main difference between TBP and ASTM, and that's why the name itself is a true boiling point. More of the fractionation is happening. The specific method which is followed or reported in a literature as an ASTM D86, this is what is a standard nomenclature, ASTM D86, which is considered as a standard for testing whether you are handling gasoline, kerosene, diesel. So ASTM D86, only the change is when you are moving from gasoline to a diesel, then the sample quantity will change. Instead of 100 ml, you need to have 125 ml. That is only the change. All other setup and everything will remain same. There is no as such change in the case. Now, this is what is an ASTM distillation. In our earlier class, somebody has asked already, and in our WhatsApp group, one student have already shared that image itself for ASTM distillation. But I have added that again here, and I wanted you to understand what I'm talking about. So this is what is a flask which has extended. This is extended surface, and the thermometer is in place, and we need to ensure that it is measuring vapor temperature. The sample whose test need to be carried out is placed in this particular single neck volumetric flask, and then depending on the sample, it may be 100 ml or maybe 125 ml. So 100 ml sample is charged, then it is closed properly with a casing covering, and it is started to heat. Again, there is a condenser which is connected, and for this condenser also it must be a copper condenser. So they have specified everything, what should be the dimensions of the condenser, diameter of the condenser, what should be the material of construction, how the cooling need to be done. So cooling must be ice water bath only. That is what is they have ensured. So ice water bath must be placed, and then in between this, there will be a condensation of the vapors which are generated in the round bottom flask will be done, and then the volume collected will be noted down. Volume collected, so it is again a volume percentage against a temperature. So if I am getting it here, maybe 100 ml sample is charged, if I am getting 10 percentage or 10 ml is collected as a distillate, so what is a temperature, what is an initial boiling point, it is called as an IBP. And taking it forward for a 10% volume collection, what is the temperature requirement? Same way, 20%, 30%, 90%, 97, 98%. So typically the ASTM distillation will not be complete unless and until 98% of the sample is collected as a distillate. So for any commercial sample, it may be petrol, kerosene, diesel, 98% sample must be distilled. That is what is a minimum requirement is. And again, when I'm talking about distillation, so we need to complete this experiment in maximum 25-30 minutes. That is another condition. So for that, we need to mention and maintain a distillation rate as well. Distillation rate as well. So this is how it is look like, and a setup is. So here the thermometer, its calibration is also specified. The distillate collection method is also specified, and everything is reported in the ASTM D86 standards, D86 standard. And this is how it need to be done. Again, when I am talking about this ASTM standards, it is a manual experimental setup, which will cost you maybe around 15-20,000 only, 15-20,000. I have used one more advanced setup. So same experiment, ASTM distillation only, but it is completely computerized data generation, and it is automated data generation, and the volume requirement is also very less. It is only requiring 10 ml of the sample. But that computer controlled ASTM distillation is costing me around 18 lakhs rupees. 18 lakhs rupees. So maybe around 20,000 to 18 lakhs is a transformation which can be observed, and that is highly sophisticated equipment what we are talking about. Data is comparable. So this whatever data you are generating here and that data is comparable. You can compare that data, but the costing changes drastically based on the sophistication which are available and made. So they have reduced the sample quantity. They have basically connected with a control system, controller, a software is developed, and the computer results final data is generated. That's how it is done. So in many refineries, when we talked about, they have that computer controlled ASTM distillation, but in our